Okay, I'm Dracono99, not going to use any special voices for these. This is, well, it's going to be basically my sort of tutorial series on C++. My intent is to show you guys how to basically make your own game from the very basic ground up type thing. I don't have any sort of examples here ready, I guess. So I'm not an expert level programmer by any means, but I'm not, a complete novice. I've been doing programming for over a year now. You guys have seen some of my other stuff. My physics engine is doing pretty good. It's not finished by any means. It's probably never going to be finished. That doesn't mean it's not going to be used. It's just sort of a coding thing. You're never truly done. I mean, even the games that are out now, they're not actually finished. If they were, they wouldn't be buggy at all. But since they are, they're not actually finished. So, that's a discussion for another time. Let's start off with what I'm using. This is Visual Studio 2012 Ultimate. It's a bit of a pricey program. Luckily, I get it for free from my school. I go to DeVry University in Irving, or DeVry Dallas. I don't know why they call it DeVry Dallas. I don't know. Not really that important. Anyway, I'm not going to show you how to get the program because I only know how to get it one way. I'm assuming there's probably other ways you could obtain a copy. How you do that is totally up to you, actually. I don't know any other programs aside from Visual Studio to do this in. So if you have questions on that, I probably won't be able to answer them. I mean, I could try, but the only real programs I've used for doing this is Visual Studio 2008, 2010, and 2012. Most of my stuff was done on 2010. Recently switched over to 2012. Gotta say, I like it a lot. If you didn't notice, I do have a different sort of color palette on mine than you would probably have stock. That's just an option. I'm not going to show you that. You could find it out on your own, unless you really want to know, and then I guess you could probably message me. So, let's get into the guts, I guess. I'm not going to say this the best, but this is what I think is important to note right off the bat. Let's start with the top. I have line numbers here. This little plus thing here just means I've commented things out. Comments, well, I guess probably requires a little bit of knowledge on what you're doing. Okay, obviously a computer can't read what I wrote right here. The computer doesn't know what the hell this is. Not natively. The way you write a program is basically I write out stuff like this, and then a compiler, which you'll see running down here when I hit debug or build or something like that. You'll see it run through this stuff, and it basically turns all of this into ones and zeros that the computer can read. So don't think that just by reading this you know what the computer is going to read, because it's not always the same. In fact, it's never the same. Ones and zeros does not translate into FALSE very easily. In fact, this is probably just one, actually, but that's not important. Basically, though, comments, which is what this is, well, this is actually just a commented out piece of code that I wrote elsewhere. Not important, but comments are not read by the compiler, so you could write like a novel in here and comment the whole thing out, and just write a few lines of code down here, hit run, and it'd be fine. You might annoy the crap out of your compiler, but you know what? Compilers are part of a machine, and machines don't have feelings. So, you may end up hearing my Skype go off. I'm gonna put myself on busy here. If you see that and you want to add me on Skype, go ahead. I actually don't care. Just tell me beforehand, otherwise I probably won't add you. So let's start at the top. These are line numbers, and it jumps from 5 to here because I've commented out lines 6 to 211, I guess. But we'll start with these. These are header files. A header file is either something you wrote elsewhere that you wish to include in your sort of file here. This is my main.cpp file. This is usually where we're going to start out for now. Basic programs usually are in here. We'll get to that, I guess, as we go. But for now, all you need to know is these are basically going to allow us to do some stuff without actually having to write a whole lot on our own. And don't think it's just some newbie cop-out. No one actually writes everything from scratch anymore. One, because it's already been done, and two, it's a gigantic pain in the ass, so no one does it. So, let's start with what these are. This is the IOStream header file, and this basically allows me to write to the console window, which I'll show you in a minute. This down here, I'm not entirely sure what it does, to be honest. I think I just threw that in there for strings, which we're probably not going to use that much, so this I could probably comment out, and this would run just fine, so you can include it or not when you write this on your own. I am doing dual monitors, but that's not a big deal either. This is a namespace, STD. No, it's not sexually transmitted disease. It's standard. Namespace standard. Basically, I'll show you right here. If I didn't have this, I would have to do this to output to the console window. And for those of you who don't know, this little red squiggly here is IntelliSense telling me I fucked up somewhere, and it's almost always right. It's not usually right. It's not always right about how you screwed up, but if this shows up, chances are you screwed up somewhere. If you didn't, it just means that the IntelliSense compiler type thing is lagging behind you, which happens quite a lot because I haven't finished writing the line and it's already telling me I screwed up. So, basically by including this though, I can get rid of these first couple things. I don't have to do std::, I can just do cout. So you can or cannot include this, it's up to you. I usually don't in my later programs, that I'll show you later. But for these beginner things, I'm just going to show you the basics of C++ so you can sort of get a grasp on what you're going to be doing later. I'll use it then because it's kind of helpful. So let's start with, well, how a program sort of works. You're going to need variables. If you didn't like math, you're probably not going to like programming because, well, at least in, okay, basic math, you have 2 + 2 = 4 and stuff like that. When you get to higher level math, like algebra, I'm not saying algebra's high level, it's not really, but, you know, then you got variables like x and y and whatever. Well, programs almost never actually use numbers. We usually use variables which change, hence the name variable. There's a couple different variable types. I'm going to go over some basic ones. I've got some already written out there, so I guess I'll go over these. This is bool, means Boolean. If you're familiar with Boolean algebra, then you know what bool is. If you're not, well, it's true or false, basically. 1 and 0. Most basic thing your computer's going to know. Now, when it comes to C++, if you're going to use a variable, you need to first give it a type. That's what bool is. It's a type, short for Boolean. I don't even know if Boolean will work. I've never actually tried Boolean. Let's see what happens. Yeah, it doesn't like it. So just use bool instead. That way your compiler doesn't yell at you. What bool does, I've already told you. You don't actually need the =false : or semicolon. I should mention that. Semicolon basically is sort of the end of the line. If you don't put a semicolon, usually your compiler will yell at you. So make sure that you do that. If the compiler yells at you for, including a semicolon where you don't need to, usually it tells you, and then it's pretty easy to figure that one out. Hopefully you can figure out where you do need to and where you do not need to by example. I honestly can't remember. I just sort of do it. I've been doing this for a while. I don't really know all the little technical bits. Google is your friend if you want extra information on those kinds of things. Let's go into the next variable type, which is int, or integer. I suppose I could tell you why I have the equals false and stuff there. Let's see. Okay, so Boolean, I just named it hut for no real reason. Basically what I did here is I defined the variable and then I gave it a name. That's all you really need. So I could do like bool idk colon or semicolon. I'm gonna butcher the English language and coding language. Wonderful. Basically that's declaring a variable. The Boolean idk. It's not initialized, which means it doesn't have a starting value. It's just going to have, what it's going to do is it tells the computer to say, okay, I need a spot in memory that's the size of Boolean and give me a address to it and set this data member to there. So whatever was in that address before is now in IDK, so it's garbage if you do not initialize. Now sometimes you don't need to initialize right away, but usually it's best practice to initialize right away unless you're just going to be using it, and the first thing you do to this variable is set to it. Make sure you don't do any math with it or anything like that, because it won't work, and it usually will tell you that it won't work by giving you an error of some kind. As far as the length of these tutorial videos, I don't know. I'm gonna try to keep them as sort of short, I guess, as possible. You can tell me if you want them longer or shorter, and I will try my best to oblige. Probably first one, maybe half an hour. I don't know. Anyway, moving on. This is not important. I'm actually not writing a program right now. I'm about to. I'm about to do a particle swarm optimization for the traveling salesman problem. What those are is too complicated and totally out of scope for this beginning tutorial. I can go over that later if you really need to know. But Google will be your best friend for that too. So I'm basically declaring some variables here and then initializing them. So that's what I'm doing there. Here's another sort of thing here. It's double dB equal 9000.9. Okay, integer is obviously a number. Integers don't have floating points, so you can't do 0.000 and put it in an integer. Your compiler will yell at you. It may not throw up an error, but it will at the very least, give you a warning. Which won't stop your computer from compiling, but most higher level stuff, warnings will be treated as errors because there's a reason it's a warning usually. You're losing data, something's not right. It's always a big mess. So if you see a warning, best practice is to get rid of it. Usually by typecasting, static cast, whatever. Not really that important for this particular instance. The size of an integer is 4 bytes. The size of a double is 8 bytes. Sort of a size in memory type thing. Not really that important for what we're doing right now. And then the last one that I'll mention really quickly for numbers is float. And this one is the same size as an integer, 4 bytes, but it has the ability to do stuff in using floating points. So it's sort of the cross between an int and a double, basically. It has the floating point capability of a double and the memory size requirement of an int. So it's good as long as you're not dealing with really large numbers. An integer will hold a number up to 2 to the 32nd power, which I don't really have my calculator within hand's reach, so it's somewhere around 4 million or 4 billion, somewhere around there, which sounds like a large number, but it's not that large considering there are some numbers with over 100,000 digits, whereas, this is 7. Okay, next things, let's go with char, which I'll call la la la. I'm just mashing things for this. Char is a character. So look at your keyboard, you've got Q, W, A, S, D, G, even the numbers, 4, 5, 6, whatever. Technically, they can all be considered characters. For example, I think I typed L here. Let's go with P for now. Now, this is also perfectly valid, 6. Worth noting, for chars, you need to put these little single quotes here. Otherwise, it will give you an error. You don't actually need to put anything in there. That is also, well, maybe you do. Let's put a space in there. Space works. Yeah, chars don't like it when you give them empty values. So, space is the very least you need in there. Again, these aren't terribly important for what you'll be doing later. I should mention that this is actually going to be how to make a game. I'm doing these little things here so you get an idea of what you're going to need to do. I suppose I'll go over as well sort of the core elements of a game. There's sort of 4 main elements in pretty much any game nowadays. There's physics, which you've seen my physics engine, which it's not bad, but it's not as good as I want it. Not yet, and it probably never will be, because I'm a bit of a... I like my games to be good, so I'm going to keep tinkering with it for a while. Then there's AI, which is artificial intelligence. Most games have AI cores of some kind. Obviously, if a game is just going to be multiplayer, you probably won't have AI. But, you might want to do it just for something easy, like an enemy. Enemies have AI. Sort of like a massive multiplayer thing, like, wow, you have AI for enemies, even though you've got a teammate that's a person. So, AI is usually very important. It's also not something that is, sort of well known, I guess. We're still in sort of the infant sort of stage with AI in programming. We're still working on it, basically. There's a lot of theories and stuff for AI to make it better. One thing that I'm going to mention now, sort of the misconception of AI, is like the Terminator thing where the AI becomes self-aware. That will probably never actually happen. I've coded AI before. It's nowhere near that smart. AI only looks smart. It's not actually smart. If I wanted to, I could make the AI run into a wall. Or I could make the AI avoid the wall. The AI won't actually know any different. Sorry, but we're not going to be, taken over by crazy robots in the next 20 years. It's not going to happen. Now, if we ever actually get anywhere near that level, there will probably be some sort of safeguard. People are not quite so stupid as to say, okay, let's give our AI that kind of thing. I'm not going to go into that, but just know that AI is not nearly as smart or as good as it looks. In fact, most of the AI programming you would end up doing is actually to make your AI stupid. Not because it's going to outsmart the player. Simply because for one of the AI projects I did, I never actually implemented it, but the way I designed my AI, they were basically all aimbots. They would never miss. That's something that you actually would need to code in for AI. They have to be told how to miss. They can't miss natively unless you tell them to target something that's not the player natively. So that's something to think about, I think. Anyway, let's move on to the last bit, which is graphics. At least of the main cores. It's graphics, AI, and physics. Graphics is, well, what you see, basically. Explosions, guns, models, people, all those interfaces. It's all graphics. Now, I mentioned a sort of fourth, and that's basically gameplay. You could have an amazing physics engine, an amazing AI, an amazing graphics, but you know what you can do with that? You could make a screen that just has a bunch of blocks, and if you click on them, they reorder, and they do that via AI. I know it sounds a bit overkill, but it's totally possible. My point being that if you don't have good gameplay, amazing graphics, physics, and AI don't actually mean anything. Some games that bomb because they actually don't have any good gameplay. They're more of a tech demo. I'm sure you've seen things like that in the industry. But that's sort of one of the things that people sometimes overlook. So let's move on to the next little bit here, and that's the string type. I'm going to call it key. Now strings are initialized with double quotes, so I don't know, I'm making crap up right now. Hugs. So it's basically a bunch of characters. Technically, string is a wrapper class, which you don't know what either of those are yet, unless you're just watching this for kicks. I don't know. But basically, it's, let's go to arrays, because that's sort of what you're going to need to know the next bit on. Let's see, int, ARR, 9. Okay, basically that is an array. I guess the best way to think of this is, at least in terms of memory, whatever int would be, or, well, you get your variable type, which is int, obviously. So that's 4 bytes. What this basically does is it says, okay, what's our variable type? Int. Okay. How much memory does it need? 4 bytes. Great. I'll take 9. Basically, it multiplies that by 9, and it sort of puts a block of memory that you're going to use in your RAM. And it says, okay, well, this is where I'm going to put these variables, and you can access any of them. So if I wanted to, I could do ARR. One thing that people often get confused is I initialize the array of size 9. However, to access the sort of parts in it, it starts at 0, so the last element is actually element number 8. If you tried to access element 9, it would most likely give you an error. If it didn't, that means you just grabbed memory that you had no idea what it did. It could be part of your operating system, which is the worst case, because you may have just blue screened and you can't do a darn thing. So be very careful with this. One of the things I recommend that I will talk about maybe later in this video. I'm trying to keep it at 30 minutes or less. We'll get to that maybe later. It's standard template library vector. It will not allow you to access that element. It will throw an error in your face. Let's call this element 0. Now, how you initialize an array is up to you. You can Google how you want to initialize it. Why I got into arrays right now is because basically a string is an array of characters. Well, technically I think it might be character pointers, but the point being you could sort of basically string is an array of characters. That's really all you need to know for this basic stuff here. Now obviously I want to make something that you could actually do, so I'm going to quickly eliminate all of this. Let's start with some really quick basics, now that you've got sort of the scope of what I'm trying to do here. Okay, so I showed you cout before. Cout basically means console out. So I'm going to write to the console window. These things here are the less than operator? I don't know. I always get confused, but that's the direction you need for outputting to the console. They'll output anything, so I could do, you know, this, and that's totally valid, though you wouldn't really need to. For the start, let's do hello world, which is, you know, just kind of the, okay, I can't spell, but that's going to be normal. So there's hello world. How you do this is up to you. There's a null terminator thing that you can put on the end of a string. I can't actually.
What are you doing, school?
I'm trying to do a tutorial here. Okay, sorry about that. I'm a college student. I live with my mother. So what? So that's sort of how you would do that. To get back on topic, there's a null sort of a character terminator thing you could put in the string. I never use it because I think it looks kind of messy, so I always terminate my sort of strings with end line. This will basically, it's like when you're typing in Microsoft Word or something and you hit the enter key, it would go to the new line. So this will compile, but before I do, I want to mention one last thing. This system pause down here, I put it in there because in Visual Studio 2008, when you hit debug, which is this button up here, it would run through this sort of console app and it would stay open until you hit close. They changed that in 2010 to where it would run and then immediately close unless you put either this or a input character, which I will get to. Sorry for the interruption. I'll make this video a little longer so you can get some basic information on that. So these also are comments. They're commented out program pieces. They're not important for this particular scope. So I'm going to run this and you'll see hello world appear on the console. And there's the compiler outputting its compiling main.cpp, which is this. So here it's an old project, discrete math recursion. And here it is. And eventually, there it is. Hello world. Okay, press any key to continue. So, the system pause adds that sort of press any key to continue line, and you can enter out. Now let's make the program a little more helpful, I guess. Okay. Now, I'll give you a little extra something here. I'm gonna declare a string here. I'm gonna call it name, and I'm not gonna initialize it. But I just told you that was a bad idea, and it is, unless the next thing you do is basically set it. Now how you can do that is similar to how you output from the console. You can obtain info from the console window. You may have seen these on like the old computers, the sort of green blinking light, and you would type in crap. So how you do that is C in as opposed to C out, and the opposite direction on the sort of things there. So that's going to be name. Now this will only, why is it not working? Alright, well let's see why we've got red wrigglies. That's interesting. No. Odd. Sorry, I've never had this happen before. So, give me a moment here. Oh, I think I know what it is. I need to do it the other direction, I think. Name CN. Maybe. No, that didn't work either. Sorry, I haven't actually done this kind of thing in a while. I have the right header file. I don't know why it's not working. Sorry, I'm doing this live and I'm not going to edit it. So give me just a minute here. Okay, well, let's do this then. cn.getLine. Let's do name, comma, or you know what? Just do this. That works fine, I think. Okay, why is it still? Okay. I think it's because I might have the wrong string type here. Oh, 0. Huh. This is interesting. Well, I guess I'll show you how to comment out. Yeah. Let's just... Come on, you stupid thing. Come on. Let's see. Alright, well, let's try a different string type here. String. I don't know. I really haven't done this in a while. Let's see, I've done this before elsewhere. Must be a thing with my, It's not liking my string for some reason. Which is possibly caused by this. 1 second. Let me go to my properties here real quick. Okay. Nope. Still not liking it. Okay. Well, that didn't work at all. It's alright, normally I don't have any issues when I do something very basic like this. See, look, I didn't actually need all that stuff anyway. Okay, well that was weird. Okay, so, anyway, now that we can continue, sorry for that little debacle. Let's make it do something moderately interesting. Let's, you know what? Let's just say name. Okay, now what it's going to do is it's gonna wait for us to type in a name. It'll only take up to this first space, so at least that's what it'll do right now. And then it'll say hello your name. So let's just hit compile, should run fine. Obviously it doesn't say that it's asking for our name. That's one of the things I was about to mention, so I'm gonna go with Drac for now. Hello, Drac. Thanks. So, in best practices, if you're gonna, ask the user for input, you might want to say something like, please, don't misspell your name, please enter your name. I don't know why I did that. So you might want to do something like that, in which case, if you run it, it'll do something more like this. Please enter your name, Drac. Okay, hello, Drac, thank you. Okay, so that's sort of where the beginning on that is. Now, you saw me using getLine. That should have worked. I'm going to see if I can figure out why it didn't. Cin dot ignore cin dot getLine. Alright, let's try this. It's still not liking it. Okay. I haven't actually used getLine in forever. Sorry. So that was that. I don't know. You could try getLine on your own, maybe. So that's sort of the basics. Sorry, it was a bit of a debacle with the getLine thing and my mother interrupting me. So that's the start. What you can do from there is sort of up to you, I guess. Really not much, aside from sort of what I plan on doing with the rest of this. Hopefully it doesn't deter you, because I'm actually not that bad. It's just that when you get to the advanced level, sometimes you forget how to do some of the really basic stuff. Which is something some higher level programmers may mention or remember. Unless they, go back and do some stuff like this fairly often. I don't. I haven't done anything like this in a while, actually. So that's basically the scope of what I intend on showing you guys. I'll do them in order. So physics, then AI, then graphics. Graphics, I'll probably do DirectX 9 for graphics. Once you learn DirectX 9, you can learn other stuff relatively easily, hopefully. When I go into DirectX stuff, I will probably also go into some Windows 32 programming. Hopefully you guys will enjoy some of that. And perhaps through learning all of this, you'll figure out why I get so incredibly upset with some game developers out there, like Ubisoft, who can't seem to figure out how to fix anything. So, I may or may not actually release any of the source code, at least not here for some of this stuff, at least not until I'm totally finished with it. So that's sort of the beginning here. Hopefully you find some of that material. If you've done this before, probably most of this stuff not new. Aside from maybe the system pause, which some people just do cn.ignore type thing, which does nothing basically, but it will leave it open. So that's sort of the basics. I guess I'll do another one when I have some time. Thank you, I suppose. Enjoy that. If you can do something with this, that's kind of cool. There's plenty you could actually do if you wanted to. I'll go into some much more interesting stuff in the next one. This was sort of an introduction to variable types for the most part, and some basic console stuff. So do what you can with this. If you manage to do anything kind of cool, let me know. Thank you, and I'll show you some much cooler stuff in the next couple tutorials. Sorry, but you gotta know the basics before you can do anything else. So enjoy that. We'll do some much cooler stuff in the days to come. So, I'll see you all next time.